So in this video, we're going to look at the skills for quiz 6, and the calculation question is limiting reagents. So this is related to what we did in the skills quiz last week, where you're going to use a table to find out moles, but there are some key differences compared to what we did last week. So if you look at the question, you are told the mass of the lithium hydroxide and you're told the mass of hydrochloric acid. Last week, the questions that we looked at, you were only told the mass of one and you needed to use the ratio to find out the mass of the other. This week, the type of questions we're looking at, you're given the mass of two things, and that is going to affect how you do the overall calculation. So if I look at my table, I've drawn it out like I've done before: mass, formula mass, moles, and ratio. I'm given information about lithium hydroxide, LiOH, so I put lithium hydroxide in my table. I'm given information about hydrochloric acid, HCl, so I put HCl into my table. And again, I write that formula exactly the same way as it is in my balanced equation. I'm given the mass of lithium hydroxide, 16 grams, so I fill that in. I'm given the mass of hydrochloric acid, 10 grams, so I fill that in. I then need to find my formula mass using the numbers provided. LiOH, I've got 1 lithium, 1 oxygen and 1 hydrogen. 7 plus 16 plus 1 gives me 24. HCl, 1 hydrogen, 1 chlorine gives me 36.5. Once I've got mass filled in and I've got formula mass filled in, I can find moles. So you're using the same formula triangle as last week, the G Mr. Moles. In order to find moles, it's mass divided by formula mass. So here it's going to be 16 divided by 24, 0.66. That answer gets me my first mark. And then over here, unlike last week, I do have all of the information I need to calculate moles without using ratio. So that's what I do. I take the mass 10, the formula mass 36.5, and I find the moles for HCl as well. And that is my second mark. So you're finding the moles of both reactants using your table. This is different to last week, and that's your first 2 marks. Then, in your second step, you need to use ratio to calculate which reactant is in excess or limiting. So at this point, I would go back to my equation and I'd fill in my ratio. So there's no number in front of LiOH, so I fill in 1. There's no number in front of HCl, so I fill in 1. And what my ratio tells me is if I had 1 mole of LiOH, I would need 1 mole of HCl to react it with. If I had 5 moles of LiOH, I would need 5 moles of HCl. But we can see from our table that I don't have 1 mole and I don't have 5 moles, I've got 0.66 moles of LiOH. And because my ratio is 1:1, if I've got 0.66 moles of LiOH, I need 0.66 moles of HCl. You can see from the calculation that we've just done that you don't have 0.66. You've only got 0.27. You have got less HCl than you need. If you've got less HCl than you need, then you will say it's the limiting reagent. You could do this the other way around. You could look at HCl and say, if I have 0.27 of HCl, then I need 0.27 of LiOH. You look at the amount of LiOH you have, you see that it's more than what you need, and again, you would conclude that HCl is the limiting and LiOH, because it's more than you need, we say it's in excess. So to get your final marks, you need to communicate that. You need to show you've used the ratio. So I've written here, according to the balanced equation, 1 mole of LiOH will react with 1 mole of HCl. So you get a tick for that. You get a mark for that, for using the ratio. And then you need to say, therefore, 0.66 would react with 0.66. But we can see that you've got less HCl than you need, therefore HCl is limiting, and LiOH we say is in excess because you've got more than you need. So I'm going to go through the other 3 practice questions with you. The first practice question is based on the same reaction. So again, I have got lithium hydroxide and I've got hydrochloric acid, and I'm given my balanced equation. So because I'm given information about lithium hydroxide, I'm going to fill lithium hydroxide into my table, LiOH, and I'm also given information about HCl, so I'm going to fill HCl into my table. The mass of lithium hydroxide is 24 grams, the mass of hydrochloric acid is 73, so I'm going to fill those in straight away. And using the atomic masses that I'm given in my question, I'm going to calculate the formula mass. These are going to be the same as what I had above. So I've got 24 for lithium hydroxide, and I've got 36.5 for hydrochloric acid. I then need to find my moles, and I'm going to do that using my G Mr. Moles formula triangle. Moles equals mass divided by formula mass. So for lithium hydroxide, I've got 24 divided by 24, that equals 1. For HCl, I've got 73 divided by 36.5, and that equals 2. These two answers, I'm just going to highlight them. They have gotten me my first 2 marks. Now I need to look at the ratio using my balanced equation that I'm given in the question. LiOH, there's no number in front of it, so I'm just going to write a 1. HCl, no number in front of it, so I'm just going to write a 1. So my ratio is 1:1. This means that if I had 1 mole of LiOH, I would need 1 mole of HCl to react it with. If we look at what we've actually got, we do have 1 mole of LiOH, but you can see that we've got more than 1 mole of HCl. This means I've got more HCl than I need, so I would say HCl is in excess, therefore LiOH is the limiting reagent. So again, I'm going to communicate that in words. I'm going to say from the ratio, from the equation, the ratio is 1:1. That means 1 mole of LiOH reacts with 1 mole of HCl. But for my calculation, I can see that I've actually got 2 moles of HCl. I've got more HCl than I need. So I'm going to say, but there's 2 moles of HCl. So HCl is in excess. And if HCl is in excess, the other one, LiOH, is limiting. The next question is again something similar, but I've got a different equation this time. I've got sodium oxide reacting with hydrochloric acid. So again, I'm given information about sodium oxide, so I'm going to include it in my table, and I'm given information about hydrochloric acid. And when I'm writing that formula into my table for sodium oxide, I write it exactly as it is in the equation, Na2O. I don't try and change a thing. So I put in Na2O for sodium oxide, and then for HCl, I'm going to be filling in HCl. I'm told in the question the mass of sodium hydroxide is 186 grams. I'm told hydrochloric acid is 182.5 grams. I'm given my relative formula mass, so I've got Na2O, 2 sodiums, it's going to be 23 plus 23 is 46. Add on an oxygen means I'm adding on a 16, and 46 plus 16 is 46, and 10 is 56, and 6 is 62. The formula mass of HCl I've already calculated is 36.5. So in order to find my moles, again I'm using my G Mr. Moles, and this is the easiest part of it. I'm just dividing 186, divide that by 62, and my answer is 3. For HCl, I've got 182.5 divided by 36.5, and my answer there is 5. So these numbers represent the number of moles that I've got, and they get me my first 2 marks. I then need to fill in my ratio. Apologies. So I look at my equation, and I can see that the number in front of NaO2, there's nothing there, so I'm going to write a 1. And there's a big 2 in front of HCl, which means I'm going to write a 2. So for my equation, the ratio is 1:2, all right? That means if I had 1 mole, I would need 2 moles to react it with. However, I don't have 1 mole of sodium oxide, I've actually got 3. And that means I would need 6 moles of HCl, exactly double, to react it with. Do I have 6? No, I've only got 5. I've got less HCl than I need. HCl is limiting. The other way I could do this is I could start off by looking at HCl, and I could say, right, using my ratio 2:1, I know I need half the amount of sodium oxide. If I've got 5 moles of HCl, then I only need 2.5 moles of sodium oxide. I look and see how much sodium oxide I actually have. I see instead of having 2.5, I've got 3. And that tells me sodium oxide is in excess, so HCl is limiting. So it doesn't matter which one of them you take. But in your answers, I've taken sodium oxide, so I'm going to stick with that. So I've written here from below that we can see that 1 mole of sodium oxide reacts with 2 moles of HCl. You've got a 1:2 ratio. That means you need double the amount of moles of HCl. We've calculated that we actually have 3 moles. That means we need 6 moles of HCl. But we've only got 5. We've just calculated that. Therefore, HCl is limiting. I don't have enough HCl. And you would need to write that as a sentence to communicate that, just as I've done in your answers. The last one, sodium carbonate reacts with hydrochloric acid. Again, this here is your formula for sodium carbonate. So you're always going to be looking at the reactant side. You're going to be given the mass of both reactants. You're not going to be given anything from the product side. So sodium carbonate is Na2CO3. And again, I write that into my table exactly the same way as it is in my equation because I need to find the formula mass. So my formula needs to be accurate. And I'm reacting that with HCl, which is again just HCl. The mass of sodium carbonate, I'm told, is 53 grams. The mass of hydrochloric acid, I'm told, is 73 grams. And then I would need to calculate the formula mass of sodium carbonate, which I don't know off the top of my head. So I've got 2 sodiums, so that's going to be 23 plus 23, giving me 46. I've got a carbon, which has a mass of 12. And then I've got 3 oxygens, which is going to be 3 16, which is going to be another 48. So I get a mass of 100, or formula mass of 106 for sodium carbonate. And then HCl is 36.5. To calculate my moles, here it's going to be 53 divided by 106. And that gives me an answer of 0.5 moles of sodium hydroxide. And then I've got 73 divided by 36.5 equals 2 moles of HCl. And again, they are my first 2 marks. Then I need to fill in my ratio. So I go back and have a look at my equation. And I can see there's no number in front of Na2CO3, so I write down 1. And there's a big 2 in front of HCl, so I write down 2. 1:2. That is my ratio. So what this means is if I had 1 mole, I would need 2 moles. So I need double the amount of HCl. If you look at what you actually have of sodium carbonate, you've got 0.5 moles. Double 0.5 is 1. So if I've got 0.5, I need 1 mole of HCl. How much do I actually have? 2. I've got more HCl than I need. HCl is in excess. That means sodium carbonate is limiting. The other way I could do this is I could start looking at HCl. I could use my ratio and say if I've got 2 moles of HCl, I need 1 mole of sodium carbonate. I don't have 1 mole. I've got less than that. So I could say sodium carbonate is limiting. So it doesn't matter which way you do it. I usually just look at the one I've got on the left and do it that way. So what I would say as an answer, from the equation, we can see that 1 mole will react with 2 moles. My ratio is 1:2. So if I've got 0.5 moles, which is the amount I calculated I have, I would need 1 mole of HCl. I don't have 1 mole, I've actually got 2. I've got more than I need. Therefore, HCl is in excess and sodium carbonate by default is limiting. So one is in excess, the other is limiting. So the first 2 marks of these questions are easy to pick up. You're just finding moles using the same formula each time. The second mark is a little bit trickier. You need to use the ratio from the equation to look at how much you need, and then you relate it back to how much you've actually got to see which one is limiting and which one is in excess. So there will always be 1 limiting and 1 in excess. And you need to communicate that through the use of these sentences, just like I've done in your answers. The other part of this quiz is just more balancing equations. And this time you're going to add the state symbols as well. So you're asked to balance and to include the missing state symbol, so kind of a combination of what we've done in the last 2 weeks. So I'm going to start by balancing. First thing I'm going to look at is copper. I've got 1 copper on the left and I've got 1 copper on the right, so that's balanced. If I look at chlorine, I've got 2 Cls So 2 chlorines on the right, but only 1 chlorine on the left. To balance this, I can only use big numbers. And those big numbers have to be placed at the front. So I cannot just put a little 2 there. I have to put a big 2 in front. Now I've got 2 chlorines on each side. By putting that 2 there, I've also changed the number of hydrogens. I've now got 2 hydrogens on the left, but I do also have 2 on the right. To fill in my missing state symbols, copper is a metal. If it's a metal, it's going to be solid. So any metal written by itself as an element is going to be solid. The only exception will be mercury. I'm not going to give you mercury. HCl is an acid. You need to know that acids are always aqueous. You're forming copper chloride, which you're told is aqueous. And then H2, you are expected to know that hydrogen is a gas. So I'll be filling in G. The next one, H2SO4, NaOH goes to Na2SO4 and H2O. So if I start by looking, I'm going to start by looking at sodium because I can straight away see that that's not balanced. I've got 1 sodium there on the left and I've got 2 sodiums on the right. So that 2 refers to the sodium. It doesn't refer to the sulfur. To get 2 sodiums on the left, I'm going to need to put a big 2. I can't just insert a little number in between sodium and oxygen, so it has to be a big 2 in front. Now I've got 2 sodiums on each side. If I look at the other elements I've got, I'm going to count SO4 as just being one thing. I've got SO4 on the left and I've got 1 SO4 on the right. I can see I've got 2 hydrogens on the left, 4 hydrogens on the left, 2 there and 2 there. That gives me 4 hydrogens. I've only got 2 here on the left, on the right, so I need to put a big 2 there. Now I've got the right number of hydrogens on each side. And now I also need to look back at the oxygens. So I've got 2 oxygens there and I've got 2 oxygens there. So you can count the oxygens individually. So you could say I've got 4 oxygens there, 4 plus 2 is 6, 4 plus 2 is 6. And the hydrogen separately, 2 and 2 is 4, and 2 times 2 is 4. And then you can do your sodiums, 2 sodiums and 2 sodiums. And then their sulfur, I've got 1 of each. What I did was just call SO4 one thing, but you can just do it as individual elements as well. So that's your balanced equation. For your state symbols, you're expected to know that sulfuric acid is an acid. That's the symbol for it, H2SO4. So it's going to be aqueous. Sodium hydroxide, you are expected to recognize sodium hydroxide as being an alkali, so you should know it's aqueous. And then water at the end, state symbol of L. It's not AQ. AQ is only if you dissolve something in water. When you've just got water by itself, the state symbol will be L. Then it says here, magnesium is too reactive to react with water, but will react with steam to form magnesium oxide. Add state symbols to the reaction below. So magnesium is a metal. Because it's a metal, you know that it is solid. H2O, okay? Usually we write H2O as being a liquid because it's liquid at room temperature, but you are specifically told that it's reacting with steam. If you've got water present as steam, it's not going to be a liquid, it's going to be a gas. So you're expected to be able to read the question and add the appropriate state symbol. If you're not told anything about it being steam, you can assume it's liquid, but in this equation you are. You are forming magnesium oxide. So they haven't told you anything about magnesium oxide, but it is an ionic compound. I've got a metal and I've got a non-metal. Magnesium is my metal, oxygen is my non-metal. It is an ionic compound. Ionic compounds are always solid at room temperature. And then you've also got hydrogen. You are expected to know that hydrogen is a gas. Okay, so more balancing, more state symbols. But this week I'm going to expect a little bit more from you in terms of the state symbols and being able to work them out for yourself.